Hi, George Diamond here. Now today we're going to be discussing the first derivative tests. Now we're not actually going to use the first derivative test to locate maximum or minimum, not in this video. This is video number 1. And in this first video we're going to just talk about the first derivative test. We're going to introduce it. We're going to talk about increasing and decreasing functions. Now in our textbook this is section 3.3. This is we use the Larson textbook, so section 3.3, this is the first derivative test. And this is video number 1. Now, take a look at my second video on the first derivative test, video number 2, and we're going to do several examples, how to use the first derivative test to locate relative maximum, relative minimum. All right. Now, first of all, 2 rather obvious observations about a graph. First, an increasing function. Now, as x moves to the right, the graph moves up. So going from the left to right, as x moves to the right, the graph moves up in an increasing function. Okay, very obvious. Okay, a decreasing function. This is when x moves to the right, the graph moves down. So as you go to the right on your function, the graph decreases. This is a decreasing function. Now, we have a little test that we can use for increasing and decreasing functions. So we can tell, without looking at the graph, if we've got the function, how can we tell whether a part of the function is increasing or decreasing? So we have a little test to determine whether or not a function is increasing or decreasing at a particular point. Okay, first, if the derivative is positive for all x in this particular interval, in the interval from a to b, then the function is increasing on the closed interval from a to b. All right, now, if the derivative is greater than 0, so if the derivative is positive for all x in that interval, then the function itself is increasing on the closed interval from a to b. So think about this now. Say you have a curve like so. From a to b, all right? Now once again, as you look at the graph, my graph is increasing on the interval from a to b. So think about this. No matter where I pick a point on my graph. So if we locate any point, okay, if we draw a tangent line to the curve at any point on my section of the graph, okay, the slope of that tangent line is going to be positive, right? So the slope is positive. Okay, that means that the derivative is positive. That tells us that the graph is increasing. So just remember now. So no matter where you pick out, no matter what point you pick on your curve here, pick out a point here. Once again, a positive slope on your tangent line. So if the derivative is positive, that tells us that the graph itself has to be increasing. So the derivative tells us whether a graph is increasing or decreasing, right, by looking at the derivative. Now, so let's take a look at the second part of this, part B. Let me bring this here up and go ahead and erase this right here. So once again, if it's positive, if the derivative is positive, the graph will be increasing. All right, now the second part of this, if the derivative is negative, so if f prime is less than 0, so the derivative is negative on an interval from a to b, then f is decreasing. So the function itself has to be decreasing. So if the derivative is negative, then the graph has to be decreasing. So if you look at a curve, like so, you pick out any point on the curve, you draw a tangent line to the graph at that particular point. Okay, the slope of that tangent line is negative, right? So the slope is negative. Okay, that means that the derivative is negative also. So remember now, if the derivative is negative, that indicates that the graph itself has to be decreasing from left to right. So the graph itself has to be decreasing from left to right. So, and then last, part C. So the last thing I want to mention on our PowerPoint here, if the derivative is equal to 0 for all x on the interval from a to b, then f is constant on the interval from a to b. So that would be a critical point actually, wouldn't it? So let's get started. Let's take a look at a little example here. Let me bring us up a curve. So as you look at my graph, you see part of the graph is increasing, part of it's decreasing, and part of it is flat. Right, now I'm going to divide it up into 3 sections. Right, so 3 parts. Now the first part of the graph, you can see the graph is decreasing from left to right. Now No matter, now, if you pick out a point, any point on the curve, on the first section of the graph, so say right here, if you draw a tangent line to the curve at this particular point, actually at any point on the curve of the first section here, okay, the slope of that tangent line would be negative. That means that the derivative is negative on the first section of this graph. So the derivative will be negative. Now, if the derivative is negative without looking at the graph itself, it would immediately tell us that the graph is decreasing on that interval. So if the derivative is negative, the derivative less than 0, then that tells us the graph itself is decreasing. Now, on the second part of the graph, this little interval here, you can see it's pretty flat. All right, so if you were to draw a tangent line to the curve, the tangent line to the curve at this particular point, at any point on this interval, the slope of your tangent line would be 0, so the derivative would be equal to 0. That means on this part of the curve itself would be constant, so it's not increasing or decreasing. Now, on the last part of the curve, now you can see at this part of the curve, that on this part of the graph, the curve starts to increase. The graph is increasing from left to right. So if we were to draw a tangent line to the curve at any point on the last section of the graph, okay, the tangent line at any particular point would have a positive slope. That means that the derivative is greater than 0. And if the derivative is greater than 0, that tells us that the graph has to be increasing. So remember now, the derivative tells us whether the curve is increasing or decreasing. Now, so to tell whether it's increasing or decreasing, we have to know whether the value of the derivative is negative or positive, right? So that brings us now to the first derivative test. Now, I said we're not going to do any examples in this video. The next video, okay, we'll do several examples where we'll actually use the first derivative test to locate maximum minimum points. But this is the first part of the first derivative test. And this is what it says. If the derivative changes from negative to positive at some c value, then f of c is a relative minimum of f. So f of c would be the y value. So that y value would be a relative minimum on your curve. So if the derivative changes from negative to positive, now think about this. So you got a curve of some type. So like so. Well, it's better than this. So we got a curve. And on that particular part of the curve, okay, you locate the derivative at a particular point. So let's say the derivative here, as you draw your tangent line at the curve at this particular point. Now the derivative is negative. Right away that tells us that the graph is decreasing. Okay? Now you draw a tangent line to the curve at another point on the graph. Let's say over here. So as you draw this tangent line, now this time that tells us that the derivative is positive, right? So the derivative is positive. Now right away, that tells us that the graph is now increasing, right? So the graph is increasing. Okay, that means where the derivative changes from negative to positive at this point right here, now this would be c, f of c has to be a relative minimum value, so relative minimum. Okay, so keep this in mind. Now think about this. Now we're going to look at some examples later as to where we're going to be using the first derivative test to tell whether or not a function has a minimum value. And when you're looking at a graph, and once again we don't have to look at the entire graph, just some values of the derivative. But if the derivative is negative at one part of the graph and then positive on another part of the graph, the place where the derivative changes from negative to positive, right, will be a relative minimum value. Right? So this is I guess the first part of the first derivative test. This is the second part. If the derivative changes from positive to negative at a particular c value, then f of c is a relative maximum. So remember, f of c, would be your y value. Right? So the y value would be a relative maximum point. So once again, think about this. Now, if you got a curve like so, you look at your tangent line at some point on your graph. Okay, the tangent line has a positive slope, so the derivative is positive. That tells us that the graph is increasing. And then you locate a point on another part of the curve. This time the derivative is negative. And that tells the graph now is decreasing. So the graph has changed from increasing at one point and then decreasing on the other side. And that tells us that this point right here, which is c, f of c, is a relative maximum point. It will also be a critical point on your curve. Okay? So it'll also be a critical point. So this is the second part. This is how we use the first derivative test. And I said we'll do some examples in my next video. But remember now, if the derivative changes from positive to negative at that particular value, at that particular critical point, that tells us that the critical point is a relative maximum. Okay, that means that the slope of your tangent line is positive. That means the graph is increasing. And then the derivative is negative, so the slope of your tangent line we have a negative slope, and then the graph would be decreasing. So it changes from increasing to decreasing at a particular critical point. Okay, that indicates that we have a relative maximum point. Okay, this is the first derivative test. Now we'll do some examples in the next video. And so if you want to see some examples, tune into video number 2.